Hi there, my name is Jay with Server Matter and CompuMatter, and the purpose of this video is if you've got a ZFS disk that has been faulted and you need to replace it, that's a tricky time. Now in our case we're using the partition, not the whole disk, so it's going to require a new disk. But we're going to be creating the RAID on the partitions. We've already done that. And one of the things you have to make sure of is, you go out and buy a new disk, and you may find out a couple of different things. One thing we've run into is where the serial number that you get from the drive and from the Linux environment when you're looking at your disks available on the drive that's faulted is in fact different than the label on the physical disk, which makes it nearly impossible to know which drive you're supposed to pull without a process of elimination, literally pulling a drive and nail biting and seeing if that was the one that in fact was faulted that now no longer appears. That's one issue, and you really can't fix that one unless you buy your disk up front knowing that a command in Linux does in fact show the same ID and say dev disk by ID shows the same serial number in there that you see on the label. You really need to make sure of that when you install these drives to begin with. Otherwise you'll learn what I've had to learn the hard way. But that aside, I wanted to point that out. The next thing we need to do is make sure that the byte size is the same. So you buy a disk, let's say it's a different brand. If you buy the identical discs, that's fine, but 2 years later, it's probably not going to be the identical disc. And once you create the partition, the byte size of the disks that you're attaching must be the same or larger than the byte size of the storage capacity that it's replacing. And we've got some bash scripts that we've created that will allow you to make that a lot easier. And so let's step through the process. This is in large part, so that we have this for reference material when we're doing this in the future. Let's have a look. Okay, so we're in a client's server right now. Let me move that out of the way. And we're going to take a look at the status of our pool, which is going to reveal our problem right here. We have a faulted drive. It tells us what drive that is, too many errors. It has been taken offline. We need to go there tomorrow and replace that. So the first thing we want to do is we want to find out what the byte size is of the partition that we're about to replace, which is right here. We're going to replace the disk, but again, in our case, the storage is linked to the partition. In yours case, that may or may not be the case. I actually haven't done it any other way. It seems to me that there's a way to create the RAID using the entire drive and not just the partitions. I don't even know if that's true, but that we're going to run the bash script smdisks ZFS get faulted bytes. And that returns to us the partition that is in fact faulted, the dev name of that partition, and the exact number of bytes that our new disk partition needs to be at least the size of. Let me show you a little bit about that bash. Well commented, and it will show you here the specific. It takes zpool status, it greps faulted out of that, it reads through all the partitions, it finds the dev SD whatever or NVMe whatever that would go with that partition, and then it looks for in the disk by ID any symlinks that are pointing to that particular partition, and then it finalizes it by getting a block dev get size 64 and displays all the information in a nice human readable fashion. Okay, so now we're going to one of the Linux boxes here in our own store. We've got a couple of new drives, and we're using two different ones just to make sure that this bite size thing is giving them a couple of different ones, because we don't know from these different manufacturers how much space they're allocating for their own specialized software that are going to take up some of the 1 terabyte that we're hoping to get. And that's where the differences lie in manufacturers. So that's why you get one that is in fact smaller than another, and ZFS can turn you down even though they're both 1 terabyte drives. So we've created a bash script called SM Disks Unformatted. So if you plugged a brand new drive in and you run this command, it doesn't find any because I already formatted them. That's right. Okay, so ordinarily if you run that command, it's going to tell you what drives are attached to your system that have not been formatted, so you can in fact go through the formatting process. And just to show you how it does that, it's going to run ls block grep for disks in the dev environment, and then it's going to run the parted command on all the ones that it finds, and anything that returns unrecognized indicates that it's not formatted. And then it's going to find the symlinks that point to it and echo to you the symlink and the actual disk name, so you know what disks you want to go ahead and format. Now in our case, to create that partition, we create a single partition on each drive that we're using. We're going to first run the command sudo parted the drive that we're actually trying to format, make label GPT, press enter, and then we're going to follow that with sudo parted, or if you're already root, you don't need to use sudo, dev sdd, again, whatever drive label or name that you have, make part primary ext4 2048s 100%, and press enter. And that's it. That'll create your partition structure. We purposely did not create a bash script for that because we want to make sure that our technicians are very intentional on what it is they're doing when it gets down to actually formatting the drive. One thing to run a bash script to get information to view and look at, but these are fairly short commands and it makes sure that we're in. Okay, the last thing we want to do is look at the byte size of our newly formatted drive, and we have created a script for that, and that's going to be get partition byte sizes, and it asks us to enter the name of our storage device. Well, I know that we've done SDD and SDE. Those are the two new drives, so I'll start by looking at SDD, and then I'll do the same thing with SDE. And in this case, oddly enough or not, I don't know, we haven't done enough of these to know how odd it is, but in this case, both partitions are exactly the same size. Now let's compare this number to the disk that we're going to replacing, which is this number. And just for to be sure, I ran our same a bash script. You know, we ran earlier the ZFS get defaulted bytes and it provided us that. Well, we can see here that it's SDC, so we backed that up with a get partition byte size, which is our other script, and answered SDC to see if it gave us the same information, and in fact it does. Okay, so for that we've created another script called smdisks compare bytes. And that's going to ask us a question to enter our 2 byte size values separated by a comma. So we've entered the 1 byte size value that is of both of the new disks that we just purchased, and we're entering the byte size value that ends in 336 that is of our drive that we need to replace. And we are being told, unfortunately, that the drive that needs to be replaced is in fact larger than the drives that we have purchased. So in neither case will these new drives work. We're going to have to repeat that process with another drive until we find a manufacturer that does work. And And we've run into this before with these we've had some team group drives that we use in the early stages that we no longer use that have two problems. One, the serial number on the drive never matches what's in the system. And secondly, it appears, maybe a benefit normally, they use less space on the drive for their own proprietary stuff than most manufacturers do. So it gets a little bit more challenging to find a disk that can be used when a partition is created to swap out with them. But that just highlights the importance of this type of testing. If we're going to ship a customer a disk to stick in there, we can't have them find that out on the spot if a technician of ours or somewhere else is going to a customer's location. They need to know that the drive works, and there's nobody in a better position of authority to make that happen than the company or the entity that in fact set up the ZFS and installed the drives to begin with. And that's it. Thanks for watching. I'm sure this will be of value to anybody that's replacing disks and partitions in a ZFS environment. Oh, wait a second. If you like what you saw and you want to be first in line for those who receive these type of videos in the future, be sure to click this subscribe button. Thanks for watching. Bye-bye.